Welcome back, viewers. We are having a very fascinating conversation with Mr. Keith Cambron, former president and CEO of AT&T Labs, and we are talking about net neutrality, Title II, and many other interesting topics that are in the news today. So now let's open up this discussion to the students. I have some questions from the students here. So Derek Nelson wants to ask you, you held leadership positions at Pacific Bell Broadband from 1987 to 1997. I imagine this era represented a monumental shift in the way people thought about their connectivity, as the internet went from a relatively obscure concept to the center of their personal and professional lives. Was there a point in this period of time when you realized how much the potential the internet had and how important the networks you were building were going to be for the future? And how can young professionals learn to be perceptive of tomorrow's revolutionary technology shifts?
Derek, thank you for the question. That's a really great question. I remember when I realized what the internet could do. Now, remember, in the industry over the last 30 years, we describe communications engineers as netheads and bellheads. I don't know if you've ever heard those terms or not. So I'm a bellhead. I grew up in the Bell system, Bell Labs and AT&T Labs and so forth. I didn't come from the internet side of the house, DARPA, and all of the technology that came along with the internet. But in 1993, I saw Mosaic. And Mosaic was a very early browser. I believe it came out of the National Supercomputing Laboratory, and then one of the universities picked it up and sponsored it. So it was a browser, and I saw a video of an automobile turning on a pedestal, coming over the PC to a laboratory I happened to be in. That, coupled with America Online, and America Online really surprised me. I thought it was a terrible business model to mail out all these silly discs, CDs that they were mailing to everybody. But American Online caught on. And finally, because I was working in the voice network, Pac-Bell at the time, we were adding thousands of trunks every day to our switching systems. The reason was the whole voice network had been designed for people making 5-minute phone calls. They made a phone call for 5 minutes and they hung up. So all of our trunking system between the switches was based on that holding time. When the internet came along, people got on an internet connection and stayed on it for 3 days. So our trunk was tied up for 3 days. So we were adding 2,000 trunks a night. Those three things came together, and I didn't understand where it was going to go, but I knew everything had changed. So that was my epiphany when those things came together. Now, the second part of the questions is, how do you recognize new technologies, and how can people coming into their careers understand the effects of these technologies? My experience is that it's not the individual technologies that really change the way we communicate, change society, and change businesses in a substantial way. It's really when they come together in a collaborative way, some might say in a conspiratorial way, and they change those very things. They can be very disruptive. So examples, the internet, I always enjoy people talking about who invented the internet, is an example. Certainly DARPA and TCP/IP, Robert Kahn and Vint Cerf played a key role. You can take nothing away from them in the effort that was, especially Vint Cerf's effort to really proselytize the internet. However, the internet could not exist without fiber optic transmission. We'd still be using dial-up. So fiber optic transmission, three things came together. One, the laser, which was invented 10 years before we used it on fiber. Then the fiber technology itself, which took a long time to develop. And finally, something called an EDFA, which is an erbium doped fiber amplifier. A lot of engineers don't know what that is. But without the EDFA, again, we could not have long-haul, very high-speed fiber optic communications unless we spent a lot of money. So if you think rates are high today, they might be beyond the reach of the subscriber. So those are examples of technologies. And we can't forget HTML. We can't forget the browser, Netscape, Mosaic. And lastly but not least, we have to thank Steve Jobs, Koziak, and Bill Gates and company for the personal computer making it affordable. Without all of that, Wozniak, get his name right. Without all of that coming together, we would not have the internet as we know it. So look for collaborative or conspiratorial technologies that can come together to make something that doesn't exist. You can say the same thing about mobile phones. Mobile phones would not be where they are today without digital modulation advances, QAM, orthogonal frequency division multiplexing, the coding techniques. All of that really took us much further up the curve towards Shannon's limit, the theoretical limit of how much information can be put within a specific channel. But that wasn't enough. DSP processing. If we didn't have the advances in DSP, we wouldn't have been able to write Moore's Law in phones. Instead of being today the size they are, they'd be the big clunky things that they were back in the 80s. And the other two things I would add are battery technology. We have batteries today that can run 2 days on a reasonable usage, and we don't have to charge them. And finally, antenna design. Antenna design isn't touted enough, but what they have done with that is remarkable. So those are all technologies that came together that created really the mobile phone. Those are two examples of how technologies can come together. And that's what you have to be smart enough to figure out. You don't have to be a deep, really engineer, but you have to have an affinity for technology and then be able to look at it in the marketplace and understand how it's going to affect consumers and businesses in general.
The next question that I have for you is from Eric Sebesma. Eric is asking, how do you contrast the AT&T wireless network build-out with those of Sprint and Verizon and other competitors? And were the challenges and opportunities pretty similar for all these competitors?
Okay, so to understand the build-out, you have to go back to the history a bit of how those providers evolved. Back in the 80s, there was a fundamental split within the industry around what technology you should use for wireless delivery. And one used more traditional dedicated frequency technology called TDM. We'll call it TDM. So it's a combination of time division multiplexing and frequency division multiplexing. So that was one kind of technology. That path of technology came to be known as GSM, the General Special Mobile Industry Standards. Another path was with a technology that was well understood but had not been adopted widely, and that's spread spectrum technology. Verizon chose to go the spread spectrum route. AT&T and others ended up going the more traditional GSM route. So when we got to 3G technology, Verizon was using something called CDMA 2000 on the spread spectrum list of wireless technology. AT&T and generally the rest of the world, not all the world, but 80% of the world was using a GSM technology. It was called 3G. The most advanced form of that was called HSPA. I won't get into all the details of that. So what happened was the partnership that generated the standards for the fourth generation is 3GPP. They went down a more GSM track. So it was easier to go from 3G technologies and step up gradually into 4G if you're with AT&T. The speeds that the intermediate steps could offer gave AT&T breathing room and allowed them to upgrade their networks. Verizon found itself in a position where it was at a disadvantage in the marketplace with CDMA 2000. So they had to make a leap from CDMA 2000 all the way to LTE, which is an OFDM technology. So Verizon had a real incentive to build out their networks more quickly because they were not in a good place. Again, I'm not trying to say anything negative about Verizon. It's a great company. Many friends there that I've worked with over the years, I still have friends in Verizon. But they were in that situation where they had to migrate much more quickly. Sprint had a different set of problems and still has a different set of problems today. Again, Dan Hesse, he's not a friend of mine, but I know Dan, and he's a great manager who built Sprint to where it is today, roughly. Sprint started off, by the way, the Southern Pacific Railway. So Southern Pacific Railway used to install phone lines for their train service, and Sprint evolved from that. But Sprint is a conglomeration of a number of companies they acquired. Centel, Nextel, Clearwire, US Cellular, and sometimes that's easier than growing yourself organically to acquire these networks. The problem is you end up with a bunch of different technologies. So you don't have one single technology that you can invest in and scale. You have all these disparate technologies. It makes the phones more complicated. The phones have to be able to pass from technology to technology, so they need multiple radios. The firmware is more difficult. The DSP processing is more difficult. And perhaps most importantly, the back-end IT systems are different. So as you acquire these companies, each one of them has a different billing system. They have a different customer management system, different supplier system. You have to integrate all of those back office systems. So Sprint has been hampered, apart from lack of capital until SoftBank bought them, by this mix of networks that they were put together. It's worth noting that the US, I guess a year ago, had 80% of the LTE 4G subscribers in the world. So we're a small part of the billion plus people using mobile services, but we had 80% of the LTE. The reason is Verizon Wireless, Verizon, AT&T, and some others, but primarily those two, by and large, made the investment and rolled out LTE more quickly than anybody else in the world. Europe is way behind on the rollout of LTE. I believe part of the reason for that is the regulators in Europe don't want any particular wireless company to get very large. So you have a lot of providers, and they have trouble getting scale to justify the rollout of LTE. It takes a lot of capital, and you can only make a return on that capital if you can do something at scale. The US, with two major providers and two smaller providers, the providers still have enough scale. Verizon and AT&T each have about 100 million subscribers, and so that's big enough to be able to justify the investment. China has been slower to roll out LTE, but that's a different set of issues. China Mobile has 700 million mobile subscribers, 7 times more than either Verizon or AT&T. But they have a captive market. And there are only 3 providers: China Unicom, China Telecom, and China Mobile being dominant. Asia as a whole has been pretty aggressive rolling out LTE. So if you look today at the subscriber mix, I think Asia has about 40%, or maybe a little more, of the LTE subscribers. The US has about 40-45, and Europe has about 5%. They haven't rolled out LTE. so that gets to another point, which some of your students ask about mergers. Communications is a business of scale. There are many businesses of scale, but communications is certainly one. If you insist on some threshold that's much more onerous than the Sherman Antitrust Act, that 50% number, if you said, I don't believe any competitor should have more than 10% of the market, then you have to be satisfied that the capital investments will never be made because those companies can't reach scale. And so you'll end up what you have in Europe, which is a very slow rollout of new technologies.
So Eric has a similar question even for the cable industry. So he wants to know, on the cable side of the industry, how do you contrast the build-out process for Comcast and Time Warner with the accomplishments of AT&T Labs? And is there any hope for more competition and new players in the cable side of the industry? And this probably goes back to our earlier discussion about the lack of competition at the local level, where people have only one or two providers to choose from. What are your thoughts on that?
Okay, let me touch first upon the technology differences. Again, if you look at history, things become clearer. The telephone company and the telephone technology really grew up with the objective of delivering a 3 kilohertz, a very narrow band signal to somebody's home. To do that, they used copper wire, which is the most cost-effective way of doing that. And it was also a point-to-point connection. You have a dedicated connection from your house to the central office. Cable companies grew up as broadband providers from day one. The old NTSC standard is a 6 megahertz standard, so to deliver one channel, you need 6 megahertz. A typical cable network called hybrid fiber coax today delivers a gigabit down that cable. So when broadband, back in the early 90s, and we talked about the epiphany of the internet, when that became clear, the cable company and the cable engineers has an objective to put 10 megabits on a 1 gigabit system, right? So you're going to use 1/100th of the bandwidth to provide the service. I've designed cable networks, I've designed hybrid fiber coax networks. Pretty easy in some sense, but it's a very tractable problem. Let me put it that way. The telephone engineers had to figure out how to put 10 megabits per second on a 3 kilohertz wire. Okay? Very different proposition. How do you take something that was designed to carry 3 kilohertz, and so for simplicity, we can say 3 kilobits, and turn it into something that can carry 10 megabits per second? Fortunately, we had a lot of bright people like John Chaffee at Stanford and others who came up with DSL, and we were able to do that, not as efficiently in some sense, or certainly not as easily or inexpensively as the cable providers. So that's really why it has evolved the way it has. As far as hope for new competition, we're going to have to see a transformation in the next decade, and it should have already started, and I'm sad to say we're far behind, and that is away from the wireline voice network. So copper pairs, there are well over 1,000 or maybe 2,000 telephone companies out there today. So these are small telephone companies, some are large. Frontier is a large telephone company, Centel, that have wireline phone service. Subscribers are leaving the wireline phone, the old POTS telephone, at a rate of about 6 to 8% per year. So every year their subscriber base lowers. The maintenance cost of all of that cable and all of those offices doesn't go down with the subscriber count. So you've got a cost that's almost a fixed cost every year, but your revenues are falling. Where does that network go? The reason Verizon and AT&T stayed in the business is because they no longer consider themselves a telephone company, they're wireless and broadband companies. So AT&T is still very much planning on delivering more fiber to the home to replace the copper wires, although it looks like Verizon may be getting out of the business. The only ways to get to the home that I know of are three technologies to deliver broadband. By broadband, today, at least the administration says it's 100 megabits per second. I wouldn't argue with that. There's a law you and your students may be familiar with or should look up called Nielsen's Law. And broadband demand to the home increases at a rate of about 40% per year. It's also in my book, a small, unabashed advertisement. But the only way to deliver 100 megabits per second to the home is cable. DOCSIS 3 does a good job of that. Fiber to the home, or small cell wireless. Small cell wireless would be the other way of competing in the broadband arena. Interesting announcement yesterday, Charlie Ergen, who was the chairman of Dish Networks, is going to become the CEO of Dish Network again, taking his old job back. Dish Network owns more spectrum in the 100 largest municipalities in the United States than does Verizon. He has no wireless network to speak of. So here's somebody who has loads of wireless spectrum, but has no mobile phone service. What's he going to do with it? One thing he might do is build broadband to the home as part of a larger strategy. So watch small cell wireless, and I think 5G is going to take a long time to evolve. You can do small cell wireless with 4G LTE quite well with MIMO technology. So I would say that's the only hope for competition, because the economics just don't justify building another cable network in your neighborhood or building multiple fibers to your home.
So now let's talk a little bit about your personal experience in the industry. So Eric has another question for you. He wants to know, for those of us who have engineering backgrounds and but are management oriented, what was your personal strategy to balance your responsibilities as CEO of AT&T as well as providing technical leadership to that organization? Was it difficult to wear both these hats?
Okay, so really, let me separate two different aspects that will answer this question. Leadership and management are two different talents, and they're really fairly distinct. Leadership, I didn't learn in my career as a communications engineer. I learned as a naval officer. So that was probably the best leadership training I ever had. Management skills are technical skills for the most part. And I learned those in my years as a consultant. I was a consultant with a big 8 accounting firm. I was in their technical consulting department. So management is about what? Management is about managing schedules, managing money, and managing performance. If you think about delivering on a big project, does the end product do what it's supposed to do? Do you meet the quality standards? Do you meet the performance standards? Did you produce it on time? Did you come within the time schedule allotted and budget? Did you do within the funds, or hopefully below the funds that were allocated to you? That's management, and that's an extremely important set of skills. Leadership is about who you are and how you treat and interact with the people you work for you, the people you work with, and the people that you're responsible to. It's about personal integrity, communications, holding people accountable, making sure they understand what their accountability is, and letting those people hold you accountable, because you have obligations to them, whether they work for you or whether you work for them. It's about how you conduct yourself and how you expect others to conduct themselves. So leadership skills are very hard to teach, but you need to do it by example so that people see you and they want to emulate you. And you know good leaders when you see them, but that's the very hard thing to teach. Management can be taught. It takes courage to be a good manager because you have to tell people no, and you have to do it in a way that's compatible with the work environment and it's professional. But you do tell people no. So those are some of the advice I would give your students.
Okay. So the next.
Let me say one more thing, because the question was technical leadership. Realize that I had 2,200 people working for me. If you count contractors, about 1,600 were scientists and engineers. I can assure you at least half of them were smarter than I am. There's no question in my mind. So technical leadership doesn't come strictly from the person at the top. Your job is to understand the big problems in the business and to try to get the right talent focused on those problems and to clear any underbrush that gets in their way so that they can't solve those problems. Technical leadership, some technical leaders think they have to be the smartest person in the organization, or at least have to be seen that way. Not really necessary. It's helpful if the people that work for you that are engineers know that you can do what they do. I design circuits. I design circuit boards. I have built software systems. I have 10 patents. All of my patents went into the network or into real products. My software is out there running today. Now, I had other engineers work for me that had a lot more than 10 patents, but the engineers knew I had walked in their shoes at least some step of the way. So that's also helpful for technical leadership.
Well, this question, the next question follows up on the discussion we were having earlier about the rate of growth for demand for broadband services in the United States. So Debbie Marsh has a question for you. Can the US sustain the rate of growth and the use of our network infrastructure? And another second part of the question is, what is the next most exciting development coming out of this industry? And what do you think it would look like in 20 years from now?
Okay, Debbie, the first questions are easier to answer than the latter ones. So if you go back to 2008, roughly 2010, in our backbone network, these are tier one, what are called tier one providers, AT&T, Verizon, BT, Orange, if we look globally. On a single fiber, we could put 40 wavelengths of 40 gigabits per second in about 2010. By the time I left the labs in 2011, well, that was about 2008. By 2011, we had demonstrating and we're getting ready to put 160 wavelengths, not 40, quadruple wavelengths on a single fiber. Each wavelength, or each color of light, carried 100 gigabits per second. So our capacity to scale the backbone was going up roughly equal to Moore's law, we'll say. The PhDs in physics I had that worked on optics told me, and I assume it's still true, that we believed we could put 320 wavelengths on a single fiber, and that we could get to 400 gigabits per second. But at that point, they believed, at least many of them believed, that we were at the boundary of Shannon's law or the boundary of what physics could do. After that point, we can no longer economically scale the backbone. So we have to find some other way to deliver the traffic. This gets back to my point about content providers not paying for anything, and we're creating a network we can't sustain. If you have larger and larger data centers that require more and more transport to deliver the content to the subscriber, you get to a point where the backbone network is carrying far more traffic than it needs to carry. Companies like Akamai, who's been around a long time, have a much better solution. Move the content much closer to the subscribers. So we can grow technologically. We probably have another half dozen years, maybe a decade, where we can continue to scale the optical systems and the routers and stay with the current business model where content providers can get a free ride. But we're going to reach a point where that no longer works. And unless the content providers and carriers can work together and design so that the whole solution is economical, we're going to have problems. So that was the first question. Second question is, what's the most exciting development coming out of the industry? I'm not on the cutting edge, so I couldn't tell you what's in the laboratories today. Certainly two things that I think are exciting are IP version 6, and you can look into that, but by the way, it flies in the face of net neutrality, so you wouldn't get the benefits of IPv6 with net neutrality, most likely. The full benefits, I got to be careful. You wouldn't get the full benefits. But IP version 6 means there are more IP addresses than there are grains of sand on the earth. So your light bulbs have IP addresses, your watch has it, your wallet, your shoes. We actually have shoes with IP addresses, by the way. And when they move, they keep their identity. That is so crucial. You can get push services. So services can be pushed without going through this complex thing called natting. So IPv6 has a lot of potential if we don't tie ourselves into knots with government regulation. Associated with that is a technology called web real-time communications. The reason we have so many security problems on PCs, I think probably a quarter of the PCs in the United States have a NetBot running on them. They have malware running on it and the users don't even know. The reason is we crammed our PCs full of software that we don't really need. If we go to cloud services, the way businesses are, we can have great security in the cloud. We have a very cheap terminal device that has a very capable browser and an internet with class of service and IPv6. So you can have Microsoft's Office Suite. You don't have to load any software at all. It's run through a browser. So if we can go in that direction, security gets easier, terminal devices get cheaper, the displays will be great, and whenever I go visit my friends, I end up working on their networks in their homes. The reason is nobody can understand home networking. By the way, I have on YouTube a series on how the internet works, if any of your students would like to see that. But home networking is very complicated, and it's IPv6 and class of service across the internet would do so much to eliminate these issues. I hope we finally get there. As far as what the next great innovation is, I'm just not smart enough, and I'm not close enough to the technology to really tell you.
Well, Keith, this has been a very fascinating discussion. We have many more questions for you, but let's take a short break now. And viewers, please join us when we come back after the break in the next segment.